Alright, next one is we gotta deal with the shortest distance between lines. First, we deal with the intersection, actual intersection or not between two lines. Then we deal with visibility, which one is on top of what, and then now we're gonna deal with the distance between the two lines. If there was no intersection, then we would have a gap between them, and what is the distance in between the two lines. Okay, so let's take a look at it. So this is a continuation of our example, First, we determine the intersection. Second, we determine the visibility. Now we're going to determine the shortest distance in between them. And here, we know that intersection does not exist. We know that the CD is above AB, okay? Okay, so our projectors right there connecting the corresponding points between the front and your top view, which is your horizontal view H. Then we're going to construct our full line, your reference plane. And we'll have to find something, the full line got to be parallel to one of the lines. You can pick one of the lines and out of that two views, all right? So we will pick AB, okay, in this example. And we're going to get our second full line parallel to that line, okay? Because it's easier to draw in this way, because in this example we have space on this side, so depends on how you want to do, either this way or this way is better. So AB parallel to the second full line. Your projector lines coming out from your front view do the same thing. Direction of your distance, right? Measure. Yeah, we are going to project it to this direction, the same dimension as that, and we get all of our points. We are going to extend again. This line is your edge view, okay? Don't forget it. Extend again, and the third full line, okay? Direction, our dimension going that direction, so our dimension going this direction for your measure and transfer. We get the points, right, and connect them, So your AB is right here. It's on the same line, so you got A and B, a point. Then you have your CD, okay? This is your full line in between that two views, so you get D and C, Go all the way back again to C, So start it, Full line, direction, measurement, another full line, directions, measurements, connect all of it, okay? That's how we end up getting our right side view, yes? So this is your first primary auxiliary, and second, which is your secondary auxiliary, okay? So now, then we're going to measure between the secondary and the primary, and we need all of that measurements. And we call them we will get all of our location data, and your reference plane are your full lines, okay? So don't forget that. And we're going to transfer the information to the third auxiliary view, which is your tertiary, okay? So coming out middle view, primary auxiliary view, secondary okay? I just call it secondary the secondary auxiliary view, and then your third, which is your tertiary auxiliary view, and we're getting the same thing. Your measurement direction, or your measurement direction of your points from this full line is the same as your measurement directions, okay? That way, from this full line to these points. Connect them, okay? Now here is your crossover here, see? On your right side view. So this is the point, the lines at which the lines are the closest to one another, okay? And this is your true size and shape, okay? Why? Because we projected it, 1 and then 2 and then 3. Don't forget, we started out with a parallel to this first full line, and then get our true length, and then project it on and ended up here, and that's the this is the you know, like the point, your intersection point, okay? Apparent intersection, actually. We just call it crossover is better, I guess. The crossover, because they're not actually intersecting, they're just on top of each other, yeah? And this is the closest, yeah, to one another. So let's see. So we have to find the shortest distance. So we're gonna project, all right, a crossover point, which is this guy. And of course, we're drawing, there's a little green line every time we draw a projector from the crossover, yeah? So this is our third crossover, and we're gonna draw the projector line, yeah, coming out. Of course, you have your CD here, yeah, on your secondary auxiliary, yeah, going on the BA, which is your point of that line AB on the secondary auxiliary view. And we're gonna draw the same thing, okay? For other views. So here, this is your primary auxiliary view. Yes, we're dealing with the CD line, and this is your AB point, and this is your CD line and AB line. Okay, straight down. Okay, shorter distance are usually perpendicular. Okay, don't forget that. I want to point that out. So here, yeah, the perpendicular distance is the shortest distance between any two skew lines. So here we go. We'll go to this. See, we draw that way, yeah, straight down from CD, okay, CD to BA straight down. That's perpendicular. Here, CD to BA, okay, straight down, perpendicular. Your CD is right here, and the BA straight down, okay, perpendicular to each other. So trying to find the shortest distance in all views, yeah. So when you look at the tertiary view, the connecting point where they perpendicular to each other is, we can see it is on top of each other, a point view, yeah. And all others, you can see the line, yes, green line, yeah. So your secondary view is your true length, and then the primary auxiliary view is the something that is parallel, right, to the full line, and then you have your front and then your top. Okay, see that top, there's also, see this little CD perpendicular, yeah, to B. Kind of distorted, but it goes straight, yes, down. So if we trace back, yeah, this is your front view, and here is your parallel, yeah. So therefore this guy, right here, which is AB, which is here, yeah, is your true length. From true length, we've got the secondary auxiliary, okay. Okay, so what is this? Sorry. Okay, so yeah, that's it for this section. Your true length is right here, ABTL. Okay, parallel is right here. You can see it very clearly. The shortest distance is here because it's point to point. The rest of them has some particular distance from each other. Okay, all right.